So let us get going. So in this module, what we've been doing so far is we've learned how to solve triangles. Now, what do we mean when we say solve triangles? We mainly mean to find their sides, to find their angles, and we learned about something called the sine rule, and then we learned about something called the area rule, and then in the last lesson, we were talking about something called the cos rule or the cosine rule. And in these statements of the rules, the little letters are the sides and the big letters are the angles. Okay. Now, one of the things we're moving towards is knowing when to use what rule, and also how to use the rule effectively. Now, in the last lesson, we used this rule, the cosine rule, to find the sides of a triangle. But you can also use the cosine rule to find an angle in a triangle. And so I just want to show you, if we rewrote this, okay, if we rewrote this cos rule to make the angle the subject of the formula, we could use the cosine rule as a tool for finding angles. So let's just have a quick look at how we would do that, and then we're going to do a question. So if my cosine rule looked like this, and I really wanted to have the cos c by itself, I just want to show you how we can get it to look like this. What I'm going to do is I'm going to move this to this side, and it's going to become 2ab cos c. And then I'm going to move the c squared to this side, and it's going to become minus, and we've got, let's see if I can do this, equals a squared plus b squared minus, let's do this, minus c squared. And I just want to take a moment and see if you all understand how I got from here to here. Now, I'm not finished yet, but I did do some algebra to rearrange things. Give me a thumbs up if you understand the logic I used so far, and give me a thumbs down if you feel like I lost you there. I'm still just playing with algebra at this stage, but it's going to be the foundation for the... Okay. So all I did was I took the whole of the last lesson. We spoke about how we could kind of use this. Okay, so I can definitely see I've lost some of you here. So let me slow down for a second. And if we look at the C, let's have a look. Let me plug this in quickly. Okay, so that's going to be that. Let's have a look. So when we wrote the cos rule from the last lesson, we focused around the side being by itself. But now I want to get the cos c by itself. And so all I'm doing is, imagine if I moved the c squared across to the other side, I would get a squared plus b squared minus c squared. And then I'd have this minus 2ab cos c by itself. And I'd have 0 on the side, but there's nothing there. Now I'm going to move this across, and I get it from a minus, it becomes a plus. Yeah. Now then, the final step to get cos c by itself, maybe somebody can come online and tell me, what is the final thing I need to do to get the cos c all by itself?
So can
Yes.
I say it? Okay. So we're going to move that 2ab over to that side. So since it's multiplying this side, it's going to...
Yes. Okay, I lost someone there a little bit, but I think I know. what was going on. It was move it to the other side.
Yes. Over
Perfect.
to AB.
And this C over here is an angle. Okay. Now, what's interesting is what this says is I can find the angle C if I know the three sides in the triangle, the A, the B, and the C, and then I use them again here. The main thing I want to point out is that the angle which is by itself, right? The angle that I'm trying to find, and then we're going to practice this. So I know it's a bit weird at first. This C is the same. That's the angle. This is the side, and that's going to be the -1 over here. It sounds a bit weird saying it like that, but just remember that relationship, and let's try and apply this idea to an actual example, because I feel like I'm too much algebra and not enough visual. So let's say, for example, I want to find this is a triangle with three sides. And say I want to find angle A, which is this one up here. Now, in the previous lesson, what we would have done is we would have written out like kind of the cos rule like that. And there's nothing wrong with that. The cos rule does say that. Okay. But in this case, I'm not looking to find side A. I already know what side A is. Side A is the 7. So now, instead of memorizing this formula, I'm going to learn how to write down the cos rule in terms of angles. So step 1 is I'm going to write the cos of the angle I want. And then on the other side, I'm going to have a fraction. So that's all we have to remember so far. If you look at what we did earlier in the lesson, if I've got three sides, and I want to find an angle here, I can use the cos rule where it's rewritten in terms of its angle form. But you have to know how to write this down kind of from your head. So if we think about what is on the top and what is on the bottom, I remember there was always going to be a 2 on the bottom. Okay, there's always going to be a 2. And then if you look at the angle I'm trying to find, what are the two sides that are next to the angle that I'm trying to find? What are the length of the sides that are next to the angle I'm trying to find? Who would like to tell me? Okay, it's going to be 5 and 8. Exactly. So you go and you put these here. 2 times 5 times 8. Then on the top, you'll remember that there were quite a few squares and there was a minus something at the end. So there was something squared plus something squared minus something squared. And the minus will always be the side that is opposite the angle you're trying to find. So what is the side worth that is opposite the angle I'm trying to find? Yeah, it's going to be 7. So I put 7 there. And what do we put here? Well, we just put the other two sides that were involved. So not the one opposite, it's just the ones that are next to. Okay, so now, at this point, we still haven't found A, but this is where our friend the calculator comes in. So maybe I should share my friend the calculator. So let me pause that for a second. And where are you hiding? Give me a thumbs up if you can see the calculator.
It's on now, sir.
Is it on? Brilliant. Okay. So now we're trying to find this angle A. And in order to do that, we kind of need to get a value for all of this. But then once we get a value for all of this, we still need to get rid of this cos here. Who can tell me what I do to get rid of the cos and just get the angle all by itself? Give a moment in the chat or for inverse cos. Chuma and Morgan have said, I agree. So really, what you're going to end up having is the inverse cos of this whole big block here. So let's see if we can do that. I'm going to go to my calculator and I'm going to type shift cos, and then I'm going to hit the fraction button so I don't get confused. And I'm going to type 5 squared plus 8 squared minus 7 squared. And then I'm going to go 2 times 5 times 8. I'm going to close my brackets and I'm going to go equals. And according to this, I should get 60 degrees. So A is equal to 60 degrees. Kalinapo, well, let's see what your question is.
Can I ask?
Please go ahead. Yeah, yeah, loud and clear.
Okay. You see where there's those 5s, 8s, and 7s, where you place them on the A, B, and C.
Yes.
Can I ask, how do you know which is A, B, and C?
Okay, very important. I love it. Such a good question. So when we look at the triangle with 3 sides, okay, we're given 3 sides, the first thing you have to ask yourself is, which angle are you after? And the one that you're after, in this case, is angle A, because they said determine angle A. So when you now want to write out your cos rule, you start by saying, it's the cos of some angle that I want to find. And then you're going to have a fraction. Now, all you need to know is that there will be this structure over here, and then there'll be this structure like this. The most important thing is knowing what this thing is here. If you know what that is the side that is different. These 2 other ones, the order doesn't really matter. And all you have to remember is the angle you were trying to find is opposite something. And so the A squared, or the one that's being subtracted, will be the one opposite the angle you got here, which is 7 squared. Then all you need to do is just fill in the other 2 sides, which basically form the arms of the angle that you were trying to find in the beginning. And you put your 5 and your 8 and your 5 and your 8. So what I want to do is give you a chance to think about how to use this again. So I'm going to just bring this up a little bit. I want you, I'll leave this on the screen so that you've got a template. Can you find me angle theta using the cos rule, but written in terms of angles? So I want you to try and write the cos rule not in this form, which is what we practiced in the last lesson, but can you write the cos rule in terms of that angle you want to find? And see if you can use the template that's on board. And then while that's happening, I'd love to take questions from those who want. So Bom, let's go to you. What is your question?
Hi, sir.
Hey.
Sir,
How can I help?
I'm a bit confused on how you got your answer. Because when we were being taught this, we were told that A is the one that's like, A is the letter is opposite. So I'm confused on how your A was 5 instead of 7.
Oh, okay. All right. So the A squared and the B squared and C squared is a little bit confusing. I think instead of thinking of it like that, just think of it as the angle you're trying to find, and then think of it as how do I write this thing out? So Bom, if I had to ask you in this one, I'm going to write this one by going the cos of something. What do you think that something is that I'm trying to find in this one over here? What's it called?
Theta, so it's not theta.
Perfect. Yes. So you are after finding the cos of theta, which is down here. And then once you've got something on this side, you can work out what theta is. Now, all that you need to know is that opposite theta is this 6, and that 6 will end up being like that. Okay? That's all you need to know. This is the sort of, if this is A squared, because they're always opposite each other. But don't worry too much about A's and B's, because they can use P's, Q's, and R's as well. So it doesn't really matter what letters they use. It's about the relationship, and that's going to be the one you're subtracting. But then this part here, what do you think is going to go at the top here?
I think it's going to be 11 or 8.
11 and then 8. Perfect. Yep, that is exactly it. And then what do you think is going to go in these spots here?
It's 11 and 8.
Yep, that's as simple as that. So now what we need to do is we need to find inverse cos of this whole block. Does it feel a bit more familiar now?
Yes, but then my my question is, since my answer is completely different from yours,
Okay.
must
What's
I keep
happening?
what we were told, or?
Okay. Is your calculator on degrees? Because if your calculator isn't on degrees, there's going to be a problem, right? So that's the other thing to look for. You should get the same answer. There are multiple ways of doing this, but you should get the same answer as me if you've done all the correct working. So you should have got in this one 32.16 as your theta. Did you get that?
Yes, I did so.
Fantastic. Well, then I think we should do another one. Okay. Let me find another one for you guys. Actually, let me go up to, let's do some multiple choice, and then we'll come back and do another one. So I know a lot of students are still getting the swing of this. And let me bring that down. Okay. Here is your multiple choice question. Using the law of cosines, which of the following is a correct statement for the cos of C? And I want you to try and identify from these, which of these 4 is going to be a correct statement. And remember, we're learning how to write the cos rule where the angle is the focus. And then while we're doing that, Chepo or Chepi, I think your hand is up. Let me, can we unmute Chepi? I think he's got a question, or she's got a question.
I think they want to hear, because I see they're not joined on audio, so I'll handle that one very quickly.
Yeah, which of the 2 do we think is correct? It's either going to be B or D. And Keisha, which one do you think it is?
So now I have a question.
Okay, go for it, yeah.
So I'm confused, ne? As to
Okay.
okay, I know Kuti the number where you're going to subtract is the number opposite the angle. But then at first I thought it was the hypotenuse, because in the previous question we got the 7. The 7 was, okay, it wasn't though, but it was the biggest side. So I expected this time to be the 11. So how do we know?
Okay. If you always have to find your angle first, right? What are you looking for? And you write the cos of that angle. And then you draw your fraction thing. And you're always going to have this setup. Then there's going to be a minus at the end. Okay, minus something squared. And then there's a 2 on the bottom, and there's that. You only have to make one decision. The side that is opposite is going to go here. And that's the one that's being minused. Everything else, it doesn't matter if it's 11.9 or 9.11, as long as you put them in, right? So you can't have 11.11, but you could have 9.11, 9, 11, and you'd still get the same answer. You must have the two sides that are next to the angle, 9 and 11, on the bottom here. But it's not too hard because they're going to match what's there. So the correct answer here, if I look at this, it can't be this one, because that's 11 times 5. So the correct answer is B. Okay.
Okay, so like what happens if you put 9, 11 on top and then 11, 9 at the bottom? Are they still going to mark it right, or?
Yeah, so you need to have 11 or 9 or 9 or 11. Both of those are correct. There's no problem.
Yeah, I know. So I know you get the same answer, but what I'm saying is, let's say you put a 9 first and then 11 at the top, but then at the bottom you put 11 first and then the 9. You still get the same answer, but then I think it's all fine. Okay, thank you.
Cool. Okay, let us see if I can do another one. Let's do another one like this. And then we'll take a break, and we're going to carry on practicing after the break. Which of the 4 options do you think is correct? Okay, to me, it looks like it is indeed C. And the only thing I had to worry about was, if I've got cos, how do I undo that? I use inverse cos, but I have to do it on both sides. And so that's why I end up getting this over here. Okay, should we squeeze in one more before the break? Let's do
Mr. S.
Yeah.
Ayanda would like for you to explain why B is wrong.
Why B is wrong? This one over here.
Yes, the one we just did now.
Okay,
Yes.
perfect. Good question. Let's do that before, and then we'll take a break. So the problem with B is it's not the inverse cos. So you'll notice that when I've got cos by itself, and I want to undo cos, I can't use cos again. That would give me cos squared. What I need to do is use on my calculator, I don't hit cos like, cos like that. I actually have to hit shift, and then I hit cos, and I get that little -1, which means inverse cos. That undoes the cos that is there. Okay? But I have to do it to both sides. And what happens is, these two are going to knock each other out, but I still get left with this. And that's why I can't have a cos in front. I must have a cos, the inverse cos, or basically sitting there. So this isn't correct because it would give you cos squared as opposed to knocking it out like I wanted. Okay. All right, everyone, we've done a solid first half of the lesson. The goal in the first half was to learn how to use the cos rule to find an angle when you're given 3 sides. And we're making good progress. We just need a bit more practice. But first of all, let us stand up and turn our cameras on, and let us take care of our bodies to start with. Please do join us by turning on your cameras. And we're just going to start by lifting our arms up. Oh, that feels fantastic. And I'll just bend to the side. Oh, that feels good. bend to the other side. And then while you're doing this, I want you to look off into the distance so that your eyes don't have to get tired either. So look off into the distance, focus on an object far away, so your eyes get a break from staring at the computer screen. And then switch your arms, look off into the other furthest point. And you should feel your eyes relaxing a little bit. Okay, then let's roll our shoulders. So go 5 backwards, 1, 3, 4, 5, 5 forward, 3, 4, 5. And then I want to do some more eye exercises. So what I want you to do is I want you to just look down with your eyes. So like you're staring sort of below, then move up with your eyes. Then look to the right. And then look to the left. Okay. Then let us do some loosening. So let's just shake out our arms, and you can swing your arms and shake out your legs. And then let's stretch our necks. Okay, to the one side, to the other side. Okay, let's do a tricep stretch. Hold that. Then let's switch to the other arm. Ew, my triceps are tight. I went to the gym and I think everything's too tight now. Then let's just take 3 deep breaths. Okay, and then to finish with, let's do 20 jumping jacks. So make sure you've got space around you, that you're not going to whack anyone or anything. And a jumping jack is just this. And we are going to do 20 of them just to get our heart rate and our blood pumping. So in 3, 2, 1, let's go. 2, 4, 5, 6, 8. Yo, this is tiring. 40, 50, 60, 70, 18, 19, 20. Yo, and sit down. I definitely notice I haven't done those for a while. And let's just have a little fun mental puzzle before we head back to the cards rule. Okay, Conke and Dudu are saying the bear is 60, which, to be fair, I agree. And the rabbit is 10, according to Dudu. What is the fox going to be? If that looks like a fox, I think it's a fox. So the fox has to be 20. And that's it, really. Yeah, that's it. So that actually wasn't so bad. So yeah, I can see lots of people have got that right. And so yeah, well done. You smashed today's little brain teaser. Was a bit, we've done some pretty hard ones lately, so that was quite a forgiving one. Cool. Well, I hope you enjoyed the break. Let me know in the chat how you're feeling after that exercise. I'm always keen to see what you enjoyed, what you didn't. Did you enjoy some of the new exercises? Let me know in the chat. Okay, so what I want to do now, sorry if I'm making you dizzy, is we're going to carry on, and I want to know, I'm going to sort of start to use a few decimals. Can you find me the value of angle RST? So RST is that one. You're given 3 sides. Can you find the value of RST? And if you're feeling confused, I encourage you to ask a question like some of our students have been. Otherwise, get going with this and see which answer you think is correct. So which of the 4 do we feel is the correct one? I don't know what the correct answer is yet. There are a few comments coming through in the chat. I need to use my calculator, so I'm going to switch to the desktop view so you can all see. So I'm going to go Shift cos, which gives me inverse cos, fraction button, 7 squared. And the only thing that makes this a bit harder is the fact that you now have some fractions, which can sometimes cause a few issues, but that's why we practice, I guess. So I get 45,55, and it seems as if the people of the room have spoken, and C is what you got as well. And so we will declare that we are right and that C is the correct answer. And what you start to see is that when you use the cos rule, if you're trying to find an angle, if you've got this format in your head, you don't really need to worry too much about A's, which is an A and which is a B. You just almost know the relationship that, like this side and this side are the arms of the angle, and they're always going to be hanging out here and here and here. Whereas the side that is opposite the angle, that's the more exciting side, and it hangs out in the minus part over there. Let's do another one. Let's do this one. I don't think we've done this. Have we done this one already? Feels familiar. We have actually done this already.
Yes.
Okay, let's move on to something a bit more exciting because you guys are getting better at this. And I actually want to hear your thinking on this. Calculate the smallest angle in the triangle. Now, this is interesting. Which side or which angle is going to be the smallest one? Who would like to share their thinking on this? What's going to be the side that is smallest? Can the sides help us know where the smallest angle is? Maybe somebody could let us know what their thinking is in the chat, or so the biggest side would be opposite the biggest angle. So this would be the biggest side, that's the biggest angle. The smallest angle will be opposite the smallest side. So the angle that we're trying to find is this one over here. Given that hint, can you find me the size of that angle? It's almost magical, hey? Like we don't have a clue about either angles, but just because we know the three sides, we can use the cos rule to help us find it. So ask yourself, what is the first step you want to take? I'll give you some time to do that. I'm going to get some water, and I'll be back in a second. What are we going to do? So always remember our format. So I don't know what, I'm going to call this angle X because I can, right? We don't know what it is, but I'm just going to call it cos of angle X. And then I'm going to write this down. And then I'm going to ask myself, what goes where? And it feels like the exciting bit is 9. And then the boring bits are going to be 13, 17, 13, 17. Oh, was there a question that came up here, or are we good? Did that hand go down? Thought I saw
Sir.
Yes, yeah.
Why can't it be the angle between 9 and 17 that's the smallest?
Okay, so the question is, why can't it be this angle down here that's the smallest? Okay, the honest truth is that in triangles, there's a law that says the biggest side is opposite the biggest angle, the smallest side is opposite the smallest angle, and the middle side is opposite the middle-sized angle. Now, it might be that this drawing is not accurate. Okay, so it might be, I agree, this visually, this does look smaller, but according to, I think that this scale is wrong. So like this is, if this is 9, this, if I laid that down, this line looks like it's a bit short. So I think the drawing is just not been done to scale. That's the problem. But I totally understand your visual kind of confusion. That seems reasonable that the drawing is not to scale.
Okay, thank you, sir.
Thank you for your question. I can tell that you are keeping an eye on things closely. So, what have I got? 2 times. .47 is the smallest triangle. So 31.47 degrees. Now, because I have faith in you and my confidence is growing with every passing lesson, I want you to now find me the biggest angle in the triangle. I'm going to call it angle Y. Can you find me the biggest angle in this triangle? Nicely done, Mbasa and Cheche. See, okay, what is the biggest angle going to be in this triangle? So when I was writing it out, I got something like that. Oh, I forgot to put my fraction button. Look how quickly that can happen. So for my biggest angle, I get 99.59. Now, the last thing I want you to do is I want you to find me this angle, but you're not allowed to use the cos rule. So what is the size of angle Z going to be? But I'm not allowed to use the cos rule. What's the quickest and easiest way to find Z? Yeah, Keisha, let's go to you. Can we unmute Keisha? Can you hear me, Keisha? Okay, maybe there was a bit of a... So Morgan, and I agree, and yep, lots of people are saying it. So
Sorry, can you hear me now?
I can hear you, yeah.
Okay, so yeah, basically what you're doing, because we,
Okay.
180 minus all of it, yeah.
Yeah, so that's what I was just checking. I was checking just that you still remember there are easy ways to find angles. It's the sum of the angles in a triangle, which is what I was looking for. What did you get? Have you worked it out yet? Or... Okay, I'm getting, let's have a look. So I get 180 minus 31.47 minus 99.59. And I hit the SD button to make it easier for me, and I get 48.94. Okay, so that's this angle here. So if we think of one of the big themes of this unit, it's being like, how can we take any triangle and start to find the angles or the sides? And today, what we've really done is we focused on the moment we see three sides of a triangle, we can pretty much work out all the angles using the cos rule. The cos rule is really good at working out angles if you have all the sides of a triangle. And it's quite quick as well when you master the process. You guys are doing so. Give me a thumbs up if you're feeling confident. Give me a thumbs down if you're not feeling confident, because we have time for one more question, but I don't want to overdo it. I want to practice the level of most of the students. Was there a hand up? Okay. Okay, so what I'm going to do then, instead of doing that one, because we've done a lot of those, let's do a little bit of a mix and match one, where we start to bring the different, can they give us all the angles, but without the side? Yes, they can. But they would need to give you one side. They would need to give you one side. Yeah. Not one. Yeah. Yeah. Okay. Which of the following will help to find the value of X? I'm doing the remix now. And this is what the next lesson is really going to be about. It's going to be about how do you bring all three of these rules together to help us find sides and angles. Now, this is only good in a right angle triangle, so I can't use that one. This is the sine rule, and it's generally very useful if you have a side and two angles, or if you have a side and or two sides in an angle. So it's not that, and it's not going to be this, because this is right angle triangles. And so the answer must be C, which is the cos rule, as we've been learning about. Okay, that's too easy. You guys know that. You guys know that. Okay, what about this one? So again, for those who are new today, we have done quite a few lessons before this, but let's just have a look. What's the most appropriate rule to find the missing value x? So we've got a side, and then we've got an angle, and we've got another angle, and we want to find another side. This and this go together, and kind of this and this go together, and so you would probably write the sine rule like this. And so the correct answer would be the sine rule. Yeah. So that's what you need to get better at, is you kind of know how to do this. I'm looking for one that will challenge you guys. But I think we've run out of time for today. Tyra, you only can use Pythagoras if you have a right angle triangle. Okay, last question of the day, and I'm squeezing this in because this is a good one. Find the area of this triangle. See if you can do this. If you can do this, then things are looking very good for you, because this synthesizes a whole bunch of ideas. And maybe for those who are feeling confident, you can maybe give us a tip in the chat as to how you would find the area of this triangle. What would you do? What would be your first step? Mbali and Zanele, you're on the money. Find an angle first. To use the area rule, which we haven't spoken about very much tonight, the area rule says like a half times 2 sides times the sine of the angle in between. And you've got plenty of sides. What you don't have is something here. But maybe you can find something there. And Bomber said, find the smallest angle first. Now, the smallest angle would be hanging out down here. And so I'm confident you can find what that is. And then once you find what that is, you can use another rule to help you. So find me that small angle. Let's all find the green dot. Why am I hearing funny sounds in the background? So I'll call this x for lack of a better word. The cos of x equals something. And now I wanted that one, so that's going to be 8. And then this is going to be 9, 10. So it feels like the angle that I get is 49.46. And if the angle is 49.46, what's my area going to be? Mdudu, you do not have to always find the smallest angle. You could have found the biggest angle and it would still work. Because in this next step, all I do is I take the product of 2 sides and the included angle. So I'm going to take 9 and 10 because I have the angle between them, which is 49.46. But if I'd found this one, I would have just used 8 and 9 in my answer. So what is the area going to be for this? Now, for those who are away or you're new to Watobe, I don't expect you to be able to do this type of question, because obviously we've done lessons on the area rule before, and we're starting kind of on our revision now. But it was just nice to kind of give you a question where we used all the rules, or lots of the rules in one. So 34.20 centimeters squared.